Hello and welcome to Integrity Online course. In this video, we're going to discuss about basic kinematics, which is a branch of physics that is going to be studying about objects' motion. In short, kinematics has the definition of studies of an object's motion or movement without considering the cause of the motion of its or the movements, because to be able to move an object needs some cause, which most likely be some forces reacting and acting on the object. And to be able to fully understand the concept of kinematics, we have some related terms that we are going to discuss one by one. Okay, the first one is going to be distance, second one is going to be speed, the third one is going to be displacement, the fourth one is going to be velocity, and the last one, or the fifth one, is time. Now the first one, distance. What is distance? Distance is a scalar measurement of the amount of space traveled, and distance actually have the unit in meters or kilometers, or some use miles. Basically, it's a scalar measurement. Now the speed is also a scalar measurement that we can obtain by calculating the distance divided by time. In the other hand, displacement is a vector measurement of the amount of space traveled in a certain direction. That's what makes it a vector measurement rather than scalar. So it has direction, not only magnitude like distance. And the units for displacement is also going to be meters, kilometers, or miles, and etc. And related to that, velocity is a vector measurement that we can obtain by calculating the displacement divided by time, and the time itself, which have the definition of the amount of duration of an event. And time is actually also scalar, usually having the unit of seconds, minutes, or hours, etc. And these are some important terms that we need to understand before we can actually fully grasp the concept of basic kinematics. And I'm going to give you an example on how these terms being implemented in calculating the physics that actually happens in our real daily life. So I'm going to give you two examples. I'm gonna show you the first one. Let's say Abby visited her grandparents. So she went 40 kilometers west of her house. And after that, she then went 20 kilometers to the east to have dinner. with her friends. Now the question is going to be, number one, what was the distance she traveled during the whole trip? And number two, what was the displacement she made during the whole trip? And let's answer the first one. Since distance is a scalar measurement, so we don't need to be worrying about the direction on which someone or something is actually traveling. We just need to know the magnitude of the traveling distance. And that's why our answer for the first one, the distance, is going to be 40 kilometers, which is the first trip. And then we're going to add with 20 kilometers, which is the second trip where she went to the east to have dinner with her friends. And the total of that is going to be 60 kilometers. Meanwhile, displacement that took place during her whole trip is going to be 40 kilometers. This is going to the west, right? So it's going to the left side, right? And then she went about and go 20 kilometers to the east. Okay, and 20 kilometers to the east. As you can probably figure it out that west and east are the opposite sides, right? Going to the west, if we're facing north, that means we're going to the left side, and the east is going to be going to the right side. That means the displacement that actually occurs can be stated as 40 kilometers minus 20 kilometers, and it's going to be 20 kilometers to the west, because the distance she traveled going west is further than the direction that she went going to the east. So the answer for the displacement is going to be 20 kilometers. And that is our first example of the difference between distance and displacement. I'm going to give you another one which we can give us a better understanding of the difference between speed and velocity. For example, a runner was able to ran a 400-meter lap in 100 seconds. Okay, the question for this problem is going to be, number one, what was his speed during his run? And number two, what was his velocity? Okay, to answer this, let me give you a better look using graphical interpretation. So let's say we have a running track, right? That starts right here and also ends in here, right? The starting point of the racetrack is also the ending point. And this racetrack is 400-meter track. Let's say the runner starts from here, from the starting line, and he goes all the way there. So goes here, goes here, goes there, and actually able to finish here, right? Since the first question was asking the speed during his run, we need to calculate. So speed, as I've mentioned earlier, is going to be distance divided by time. So the speed for that is going to be the distance divided by time elapsed, right? The distance that he traveled was 400 meters, and the time elapsed was 100 seconds. That means his speed was 4 meters per second, and this is his average speed. Okay, he might not accomplish the whole lap running 4 meters per second. Maybe there's some part of the lap that is going faster, there's some others that's going slower than 4 meters per second, but in average it's going to be 4 meters per second, and that is the speed. And this is for the question number 1. But number 2, what was his velocity? And if you can see the displacement that took place during his run in a track that is a circular track, it's going to be 0, right? This distance is 400 meters and the time is 100, but displacements that took place equals to 0 meters. So his velocity is going to be 0 meters out of 100 seconds. So that means it's 0 meters per second. We can consider him not having any velocity, because in reality he actually managed to get to the initial point where he actually started moving. That means the displacement that happens is 0, because here to here it's 0 meters, but the whole trip that he actually took is 400 meters. It's 400 meters because the track is 400-meter track. And I hope that can give you some understanding of basic kinematics. We are going to continue on to the next module, where I will dive even deeper about the speed and distance. We're going to talk about velocity and displacements in the next 2 videos. And the next video we're going to discuss about more about speed and distance. And that's it for now. Thank you.